This is Module 29, Volume of Pyramids and Cones. Thing I have to kind of introduce is a formula that basically goes along with both of these figures. And the formula is 1/3 the area of the base times the height. Now, in case of the pyramid, the area of the base can depend on what the actual base is. If you see in the right here, you have here looks like a square base or a rectangular base. Here you have a pentagonal base or a pentagon. Here you have a hexagon, so on and so forth. So the base can actually vary. So it's 1/3 of whatever the base is, the big B, which I'll be referring to, times your height, which is always going to be the distance from the tip of the pyramid down to the central part, and it will be perpendicular. It also cuts the side in half, or bisects it if you draw a part here. So that's 1/3 big B times big H. Now in a cone, it's the exact same thing. 1/3 area of base times the height, or 1/3 big B times big H. The only difference is your base in a cone is always going to be pi r squared. So if you do that, just know what the difference is, what the big B is, and you should be okay. Okay, so here we go. It says find the volume of the solid. So what I notice is that this is a pyramid. It's a triangular pyramid. So that means I have to find 1/3 my big B, which is the base, times the height, which is the thickness, off the third dimension. So the big B is this guy right here, which is a right triangle. So I can say big B is equal to 1/2 my base times height. My base is going to be 4 meters. My height is going to be 6 meters. Now the height is pertaining to little b and little h, not big B and big H. That's one of the reasons why I say big B and big H versus little b and little h, because little b and little h refer to a two-dimensional object. Big B and big H refer to a three-dimensional object. So once I do this, 4 times 6 is 24, divided by 2 gives you 12. So that's 12 meters for the big B. And then the height, I know, is just 9, so then I can just plug it into the formula, which is volume equals 1/3 big B, which I know is 12, I figured that out, times big H, which is 9. So when I do this in a calculator, I will get 36, and it's meters cubed. Don't forget your units. Units is very important. Okay, so that's for the one on the left. The one on the right, same deal, only this time the base, the big B, 1/3 big B times big H. In this case, the big B is the pi r squared, because it's a cone. So big B is going to be equal to pi times the radius, which is 2.2, quantity squared. So unless it's specified, you can just use 3.14 or your pi button. It really doesn't matter. But if you do this, in your calculator you get 15.976. 1976. So that's your big B. Your big H is the height, which we already know is 4.5. So now to find the volume, I just plug it into the formula. I got 1/3 my big B, which is 15.1976, and times that by my big H, which is 4.5. When I plug that into a calculator, I got 2.7964, and it's centimeters cubed. Okay, so two very similar figures. The formulas are exactly the same, only their bases are a little different. And again, please make sure you distinguish between the big B, big H, little b, little h. So we have use volume of pyramid. Originally the pyramid had a height of 144 meters and a volume of 2,226,450 cubic meters. Find the side length of the square base. So we know it's a square base. So that means you have to plug it into your formula. We know that we have a volume formula of 1/3 big B times big H. Well, we know the volume part. So you plug it in, 2,226,450 cubic meters equals 1/3. Your big B, in this case, we know, is a square base. So that means you can either put x squared, s squared, doesn't matter. Has to be the same value squared, though. So I'll put x squared, just because you guys should be used to x, times your big H, which we know is the 144 meters, because that's what the pyramid's height is. So that's your big H, 144. So now what you have to do is you have to solve for your x squared. So what I'm going to do is I'm going to do the 1/3 times the 144. And that gives you 48. X squared equals the 2,226,000. To solve for the x squared, you do 2,226,450 divided by the 48. That gives you 463.375 equals your x squared. So if you're solving, you're trying to get rid of the squared, you have to take square root of both sides. Technically you get plus or minus, but since we're dealing with geometry, we only deal with positive dimensions. You do square root 46384.375. That gives you 215.37, and it's meters squared. Or I'm sorry, find the side length, so it's actually only just meters. Okay? So 215.37 meters is the length. Again, be careful what your units are, because in some cases you might ask to find a certain base area, the volume, or a certain segment or part of the figure. Okay, in this one it says use trigonometry to find the volume of a cone. So we have find the volume of the right cone. Well, again, we need volume is equal to 1/3. Our big B, which is pi r squared, you can either write big B or pi r squared, it's up to you, times your big H. The problem is we know the big H. We know pi, we can use 3.14, but we do not know what our radius is. But we have, it says use trig, so we have a right triangle here. So I can draw it a little bit bigger if that helps you out. It's a right triangle. We know this is 16. We are trying to find the r. So what is the relationship between the 65 and the 16? That's opposite. What's the relationship between the 65 and the r? That's adjacent. So if you have opposite and adjacent, remember SOHCAHTOA? That means we're going to use tangent because we have opposite and adjacent. So I'm going to use, to find the r, I have tangent of 65 equals opposite over adjacent. Now, the thing is, when you plug this into your calculator, usually use about 4 decimal places for the tangent button. So we have 2.1445. Anything past that, I mean, it will help, but you'll get roughly the same answer. It'll be pretty darn close. So here, you can put it under 1, and you cross multiply. So I'm going to give you 16 equals 2.1445 times r. So I'm going to do 16 divided by 2.1445 gives you roughly about 7.4609. So 4 decimal places is your radius. Okay, so we needed to find the radius. Once we found the radius, now let's actually find the volume of the figure. So all I have to do is find 1/3. So we got volume is equal to 1/3 pi, which we use. You can use the button, or you can use 3.14. unless it's specified. So we got 7.4609 quantity squared. Then we have times the height, which is 16. So you can plug this into your calculator. And I'm going to use 3.14. And you get roughly around 932.22 to the nearest hundredth. And this is feet. So it'd be feet cubed. Okay, this is called a composite figure because you have basically two figures that you know, but they're kind of smashed together. So the bottom figure here, that's your cube. How do I know it's a cube? Because I have 6, 6, and 6. The top figure, that's a square pyramid. So square pyramid. What I'd like you to do is I'd like you to pause the video and try and see if you can figure out the volume of this composite figure by yourself, calculate it, and after that you can play the video and see if you got it correct. Okay, so the solution is you have the volume of the solid is the volume of the cube plus the volume of the pyramid. So we know the volume of the cube is the side length cubed. We know the volume of the pyramid is 1/3. S squared is your big B because we know it's a square, so that's your big B, times your height. So now all you do is just plug in what you know, because you don't really have to solve for anything, any unknown part, because we already know the height of the pyramid. We also know all the dimensions of the square cube as well. So that's your S cubed. This part here, that's your S squared times the 1/3 times the thickness, the height, and multiply it straight through and through and add, and you get 288 cubic meters for the end result. So mainly in the real world you have composite figures like this, so this is a very useful skill to do. But again, just break it down into figures that you know, and apply the formulas to each one of those figures.